All right, welcome everybody to week 3, day 1 of Computer Science 40. If you have any questions about the simple calculator assignment, now's the chance to ask. It is going to be due at the start of class on Wednesday, and as a warning, the actual numbers used in the test cases that I judge you on are different from the ones that are up on the input tester. So as long as you're doing everything in a normal fashion, adding, subtracting, multiplying, dividing, checking for 0, you'll be fine. If, however, you hard-coded the things, say if the first input is 2 and the second input is 3, then the answer is 7, something like that. No. So, yeah, just be aware. And the one that I expect that will get some of you are the ones that are checking for the Declaration of Independence. So the Declaration of Independence, fair warning, could appear on any of the 3 numbers, right? So you've got the first number is the choice of operation, and then the next 2 are the operands, or the inputs to the algebraic, arithmetic, really. The Declaration of Independence, it could appear anywhere. You don't know where it's going to appear. So make sure that you check for if not cn after every input. And if you do that, you'll be fine. Okay. Stop playing League in general. Yeah, it's probably a... Is somebody actually playing League? That's funny. You put up a League of Legends promo video, and then your students start playing League. I guess that's just cause and effect right there. Yeah. Yeah. Okay. So today we are... So did you guys all understand that? Like the inputs will be slightly different. So as long as you didn't hard code anything, you should pass everything. The only thing that I expect some people will not get the point on is if they didn't check all 3 inputs for being not seen. Okay. Technically, you could probably get by with doing it once, right? Like, just kind of depends. So if I do something like this, if I read in all 3 of the numbers, I could just say if not cn once. If, however, you split it up and you do like 1 here and then 1 here, then every time you do a cn command, you should always follow it up with if not cn. Okay. So one approach you probably take towards this assignment is actually just to read all 3 numbers in at once and then check to see if an error occurred. Just like that, and that should cover the Declaration of Independence wherever it might appear. By default, it is with x equals to 1. The public test case that you guys have, x is equal to 1, y is equal to 776, forming 1776, of course. And then z is the Declaration of Independence. But in my private test case that I'll test you on, it'll either be an x or y. So if you write your code like this, though, it'll catch any, no matter where the DOI appears, no matter where the Declaration of Independence pops up with Nicolas Cage tucking it under his shoulder, running out with it, this code here will catch it. Do you guys understand? So if what happens if an error occurs is that all the cn statements after it fail. So if an error occurs here, then it won't even read into y or x. Once the fail bit is set, all future cn statements fail, and it just drops through them without doing any work. So can you run input tester? I have some trouble interpreting mine. Sure. Don't you have to see out stuff in between there? Oh yeah, that's a good point. Yeah, so you can't do it this way. Sorry. Yeah, sorry. You could probably make it work. You could probably make it work, actually. But yeah, you might have to do 2 cn statements, or more. It just kind of depends how your code's structured. I've noticed a lot of people have been writing code like this. Like if x equals 1, do this, and they'll have some more code in there, and else if x equals 2, right? If you find yourself copying and pasting the same code over and over again, There's probably a better way of doing it. And probably the better way of doing it is to put it up here instead, and then checking for the error there. Then you don't have to copy and paste that code quite so many times. And you could probably cover both modulus, because remember, modulus by 0 is division by 0. Right? Because when you modulus something by 0, you're dividing by 0 and saying what's the remainder. Division by 0 divides by 0 and says what's the quotient. Right? Both division by 0 and modulus by 0 do division. So you have to check to see if you're doing division by 0. And you could probably even put it up here with something like this. Like if x is equal to, 4, or x is equal to 5, and and z is equal to z is equal to 0, then die. Something like that. Okay. So that way you don't have to keep copying and pasting the same code over and over again. And if you're annoyed at how many times you need to copy and paste this code, well, it's because you haven't learned functions yet. Functions are a way of avoiding duplicating code. We'll get to those in chapter 4 or 5 or something like that. So, can you repeat it, please? I totally missed it. Not seeing checks for input errors. Yes. This code here means did an error occur when reading from the keyboard into X? That's what that means. Okay. How do you run your code? A.app. So the process you're going to go through over and over again is you're going to edit your source code, and again, if like the Unix things are like stymieing you, there's a tutorial on Canvas, and when you log in, it takes like an hour to go through that teaches you all the basics of Unix. This is in a Unix class. But I do go through the basics, but the more Unix you know, the better off you'll be. Okay, so you compile your code by typing g++ main.cc, and yeah, fair enough. Fair enough. That's actually a very serious warning. Okay, order of operations. Yeah, with this one, the order of operations would actually be wrong. Okay, it needs this to happen first if it's either 4 or 5 and the second parameter is 0. This is saying either if the option is 4 or the option is 5 and y is 0. So this is going to cause, if this code here would say bad input every time I did division due to order of operations. Never ignore warnings. Never ignore warnings. You should consider them like errors. Technically, this is valid C++, so it'll compile. It's just not going to run the way you think it is. Okay, and then you run your program by typing a.app. And so if I do 4, and I'm going to divide 2 by 0, it gives me bad input. I do modulus, gives me bad input. So the steps are vim, followed by compile. You guys should be using compile, I guess, main.cc. And then after that, a.app. You'll do those 3 commands over and over again. Okay. Yeah, okay. So that should be good enough for the simple calculator assignment. It is due at the start of class on Wednesday, so make sure you get it done before then. It's really not supposed to be a hard assignment. It's just really to get you familiar with the server, right? Like, how do you compile things? How do you run things? How do you run the input tester? You know, the input tester looks like this. Input tester. This is what you want to see. All 12 test cases passed. Who was asking about the thing Hesterberg? So Hesterberg was asking to interpret the calculator, and what it's showing is what your code is outputting and what my code is outputting. And these things look pretty damn similar, huh? Okay, here you're outputting a 1 when the answer should be -1. Let's pull it off so we don't reveal your code. Oh, you've got an extra space in there, that's why. So, The auto grader would actually ignore that. But the input tester is a little more strict, actually, than the thing in practice. So we compile your code, and if we run the input tester, what the heck is going on there? You've got an extra new line in there too. Let's see here. Yeah, it's going to be white space or something like that. I wouldn't worry too much about it. Even if your thing was submitted like that, I'd just give you the points. Like I'm not here to beat up students, you know, like unless I'm seeing some typo that I don't see here. Please enter two numbers. Please enter two numbers. I think you have like an extra new line maybe in there or something. So I would still give you full points on it, right? Like I said, I'm not here to be punitive. Like if it's something stupid like that, I'll just give you the points. This, however, is wrong, right? If you're outputting 1 when the answer should be -1, that's wrong. I won't give you the point for that one. But for white space issues and things like that, even if it's a spelling mistake, you know, it's not a big deal. Even it's more. I more want you to not have spelling mistakes so that I don't have to go through and manually fix the grades for 90 students. You know what I mean? Like it's more fun for you too when you type input tester and it's like all tests passed. Yeah. Okay, how do I tell what inputs are going on in the input tester through that screen? Okay, so what's happening is that it's running your program, and that means redirect input. So that's a Unix thing, and it's covered in the Unix tutorial. So this means rather than, see, normally when you run a.out, right? Yeah, I think that's what your problem is. I think you split this over 2 lines. Normally when you run a.out, you type in from the keyboard, right? 2 + 2 is 4, right? 3 + 3 is 6, like in the Rick and Morty intro, right? So the way the auto grader works is it uses a file instead of the keyboard. So this file here is actually what's going to get typed into the keyboard instead of me manually having to type 10 test cases times 90 students, 900 runs of simple calculator, which would cause me to second guess my choice in life. You know what I'm saying? So what happens is that I've recorded the keystrokes that I would type in. That's essentially what's happening here. So if you want to view that file, you can say vim and then view that file, input file 0. And it's showing you the first test case is typing in 1, which means addition, followed by 2 and 2. So this should output 4. If you want to see what file is the output, so what's happening here is that it runs your program and it's running that text file instead of the keyboard. That's what that little arrow there means. The arrow means use a text file instead of the keyboard for the input. Cool. It makes automation really nice. Like people love Unix for a reason. Like techies love Unix for a reason. Cuts down on the amount of drudge work you have to do by a huge factor. Anything that you can automate usually pretty easily in Unix. And then this means rather than sending the output to the screen, the output is going to go to a different program. And so this program here is called diff. Diff differences 2 different files. And so what's happening is that diff's standard input, the keyboard, is going to be read from the output of this program. The output of this program, rather than going to the screen, becomes the input of this program. So it's connecting the 2 programs together. So the output of one program feeds into the input of the other program. That's why this is called the pipe character. So it pipes the output from a.out into diff. And it's going to compare 2 files. The first file it's going to compare is the standard input, which is the hyphen. And the second file it's going to compare is this one here. So if you want to see what the code should be outputting, just select the code like this and say cat, right click, and you can see that it is, oh, do you have these things out of order? Maybe that's what, yeah, that's the problem. These things are out of order. So it's supposed to be addition, subtraction, multiplication, division. Please enter 2 numbers. Your code is saying please enter 2 numbers, and then it does this. Okay, that's your problem. Those things are backwards. Okay, so if you want to see what the output file is supposed to be, you cat it. Like that, cat just dumps it to the screen, or you can vim it, which will open it up. Same text file. Cat just prints it to the screen. It's usually pretty much easier to cat things than Vim, but you can Vim it if you want. And so this shows you what the output of the program should be. So the output of the program should say this line, and then 4, because we did 2 plus 2 is 4. And yeah, so here's the input, 1, 2, and 2, or I could have catted that as well, 1, 2, and 2. Cat just puts it on the terminal instead of in a separate screen. So there's the input, there's the output, and then you can run your program manually and be like, all right, I'm going to type in 1 and 2 and 2, get 4, and then you can kind of get more, you can dig into it and be like, okay, these 2 lines are backwards. Okay. So, does that make sense, Esrog? Riz, you want to look at yours as well? Okay, sure. Okay, so CD simple calculator. By the way, a lot of computer science professors still manually grade things by hand. It's not good for the students, not good for the professors, let me tell you. It takes weeks to get feedback on your homework, and when you get the feedback, you've already submitted 2 more assignments in the meantime, and you get knocked off for having bad variable names that you didn't know that you're going to get knocked off for because it takes 3 weeks for the homework to come back. There. So Riz, welcome to the simple calculator. What would you like to do? Okay, so right off the bat, I know that this is not going to pass the test case, right? In order to pass the test case, your output must exactly match the output that I give you. Okay, so if you want to look at the output file again, this is what the program is supposed to output. Okay, so it just prompts you addition, subtraction, multiplication, and division. Your code is saying, welcome to the simple calculator. What would you like to do? Yeah, you got to delete both of these. This is an assignment in precision. There's definitely some, and some students are like, I wish I could be creative with it. And there most definitely assignments where you can be creative. I'm a huge and firm believer in the creativity side of computer science. This assignment, though, is teaching you to be precise. You need to be able to look at my code and replicate it exactly, right? So you need to delete these 2 lines, and also the caps need to be changed, and you misspelled multiplication, right? And so you need to be able to replicate my thing exactly, and there's a reason for that, because in computer science, it's a combination of creativity and precision, and like logic and reason, and being able to make a code work properly. And so you need to be precise when it's time to be precise. You need to be creative when it's time to be creative. But you need to be able to do both, right? So, Reyes, you see what you need to do here. So let's test your code. 2 plus 2 is 4. Multiplication, 2 times 0 is 0. Division of 4 divided by 0 is crash. Okay. So Reyes, you need to not crash when divided by 0. So okay. So add in a check. Okay. So the input tester, when you run it, which I don't know if I ran it yet actually, it's telling you this is what your code is outputting, and this is what my code is outputting, and you need to make your code match my code. Please enter 2 numbers versus input 2 numbers, please. Right. So yeah, that's why I made a little simple assignment be the first one on the server, just because there is a bit of a learning curve to it. But trust me when I say that, like, if you look at I don't know if Zach's here. Yeah, Zach. If you want to, Zach just finished 2 years of computer science with me, and his brother also finished 2 years of computer science with me. Do you want to talk about the grading system overall, Zach? Like the auto grader, right here, Zach. Muller? No? I don't know. It might be AFK. But in general, like after you've kind of learned it a little bit, you'll see the benefits of it. You'll see there's really, really big benefits to doing homework assignments this way. And Zybooks does something similar with their auto grader on the assignments on the website. They have a bunch of test cases, and they feed it in and check your output and make sure it matches up. Okay, so time is 12:22. All right, so let's see if there are any more conditionals that we need to go through. Oh yeah, we were going to talk about Unix shortcuts. Yeah, we're going to talk about that. Then we'll talk about Booleans. Yeah, and then we'll move on to loops probably on Wednesday, and that means it's time for your first competency exam too after today. So today, your first competency exam will go up. You'll have a week to do it. It'll be 4 questions. 3 of the questions are multiple choice. 1 of the questions is free response. You're going to have to write some code. The topic will be everything that we've talked about in class so far. So conditionals and obviously variables and CN and cout, because you can't really do much in computer science without variables or CN and cout. So that'll be your first competency exam. 3 multiple choice questions. They're not designed to be easy, by the way. They're not designed to be like they're not trick questions either, but like they're not designed to be easy questions either. Because if you fail it, then you get to take it again. So I really do want to make sure that students know the material when they pass a competency exam. That's the whole point of them. It's a replacement for midterms and finals. So I could probably put up some sample questions for y'all as well, so you can kind of get an idea of the kinds of questions asked. All right, so let's talk about Unix shortcuts. So in C++ shortcuts, because like I said, the more Unix you know, the more stuff you know in general, it just helps in life. Okay, so we've talked about using tab to complete a file name. If you are on the server and you want to like edit readme, vim re tab. Okay, don't type. If you type long file names, you will make me sad. You know what I mean? It's like vim old main.cc. You can type it, but just vim old tab. That's the Unix way. Tab complete everything. And in fact, I choose file names that are conducive to being tab completed. Like instead of like when I backed up my old main, I called it old main instead of main2, right? Because if I had like copied, like if I had moved old main to main2.cc, then what would happen is if I tried tab completing main.cc, it would stop there, right? Because there's main and there's main2 and it doesn't know which one you want. And then I could type main2 and continue. So rather than creating a file called main2.cc, I call it oldmain.cc so that I can continue tab completing main.cc without any interference. So the Unix way is to accomplish as much as possible with as little effort as possible. It's the judo philosophy, right? Maximum return for minimal effort. And maybe that's the computer science person's philosophy in general, right? We like to be able to do amazing things. Like I can grade 900 test cases in under a minute, right? Because I automated it, I scripted it. When I was a grader at UC San Diego, we graded everything by hand, and we had to run all the test cases by hand. We had to log in as a student and run each of the test cases by hand. And then if they failed a test case or if it didn't compile, then I had to look at their source code and be like, all right, why is it not compiling? And try and get it to work. And it took literally forever. It would take, for a simple calculator, it would take probably not that long, like 3-ish hours maybe to do it by hand. But for longer assignments, you're talking 20, 30 hours to grade one assignment. Nah, no thanks. Cool. So, you graduated from UCSD? Cool. Yeah. No, UCSD computer science was good, but the way that, especially their lower division stuff, like this class, like at least when I took it, I'm sure it's better now. It was hugely time consuming for the students, for the professor, and for the TAs. Like it was just, and so when I started teaching here, I'm like, I'm gonna do it myself. I'm gonna spend a couple days making an auto grader. I showed the other class, by the way, my homework collection script, and I showed it to him because I was talking about vetting, right? To vet means you don't trust the input, and all of this stuff you see here, this is in shell scripting. It's not C++. I'm saying if this file exists, then do something. If I'm not root, do something. If I didn't type in the right number of command line parameters, print a message. This is how you use the software. If if the class name contains any non-alphanumeric things or an underscore, quit. If this is a program that only I run. It's a program that only I run, and all of this stuff up until now, it's all sanity checking. It's all just saying, this thing doesn't exist. This doesn't exist. This doesn't exist. I am verifying the hell out of everything. This is 168 lines of code later, and it's still just checking to see, does this exist? Does this exist? If it doesn't, then it creates a directory. If this thing doesn't exist, create a directory. Like out of the actual thing, the actual grading is actually pretty simple. I copy your source code, I compile it as you. If it doesn't compile, you get a 0. Then the actual grading is done right here. Yep. So it diffs. It runs your program. It runs my program. It compares the results. That's the actual thing. It's like 500. It's like a word count. It's 500 lines of code, and probably 90% of it is just error checking. If I wanted to write it unsafely, I could have done it probably less than 100 lines of code. They get a C for trying. Yeah, not in real life though, right? And so the point is that I spent like a day or two writing this and progressive bug fixes and things like that afterwards, in order for me to not have to run 900 test cases on a trivial assignment like simple calculator. And so the benefit for me is that I don't have to do brain numbing work. The benefit for you all is that you get your grades immediately. And with the input tester, you can know what your grade's going to be prior to submitting it, right? At most places, you just turn it in and it comes back, you got a C, and you're like, why the hell did I get a C? Now you know what your grade's going to be in advance. You're essentially running the autograder in advance, and it tells you, you're getting 10 out of 10, cool. You're getting 12 out of 12, cool. So that's they get a C++ for trying. Yeah, and so the UNIX philosophy is that. The UNIX philosophy is automate what you can automate. Get rid of all the brain-numbing drudgery. Anything that can be automated, make a script for it or something, okay? Type as little keys as possible. Maximum results for minimal effort, okay? It's the philosophy of computer science, of UNIX, and of judo. Okay, so next command line shortcut is Control-U. I use this one all the time. If I've got a lot of things on the command line, I don't want to sit there and do this. Control-U erases the whole line. And this is especially useful if you're like typing in a password and you screw up. If you hit Control-U, it clears the entire input buffer. Because if you fat fingered something, you don't know exactly how many keys there are, because it doesn't show anything. And so you just sit there and just hit backspace. I don't know. It's probably got them all. All right, retype the password. Yeah, even from the password, even when there's not characters on the screen.
Did you get enough to eat?
Yes, I got enough, Zach. Thank you.
Did you want to buy your books for English and in your first computer science?
That's funny. Welcome to Zoom education. Zach very quickly muted himself. Yeah, so Control-U erases everything in the input buffer. And it's kind of fun. Whenever I play like a video game that has like a Unix shell prompt in it, there's various hacker games you can play that pretends, like you can type ls and cd and things like that. And one of my things to tell if it's a real Unix prompt or just a fake one is I hit Control-U. And 9 times out of 10, it doesn't work because they're just pretending to be a Unix prompt instead of an actual one. Up and down arrow are massive time savers. Up and down arrow let you scroll through your history. So if you're no longer suppressed IC. Yeah, I was asking a question earlier, Zach, about how grading worked at other institutions, and I was asking you to chime in on that. So if I type up arrow, 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 it goes through my command history. Right? And then if I go down, if I go up, go down, go up, go down, go down, go down, go down, it scrolls down through my command history. So, Okay, well let me know how it goes. So that's up and down arrow. You will see people using them all the time. Even when at a certain point it'll be faster to just type it from scratch. You know, I'll see people up arrow a couple times to type ls. Just because the arrow key and the return key are like right next to each other. Sometimes they'll go back like, okay, there it is. Just because they don't want to type anything. There's a command called reformat. The reformats your code the way that I like it. The compile shell script does this for you, so it's not really that important. But here's that. So here's what it looks like, and then if I reformat the code, then it sets the style the way that I prefer in this class. You do not get marked down for style. It just kind of sets the program to look like the way that I like it to look, and it'll probably teach you good habits, maybe. I don't know. The compile shell script does a reformat for you. So if you don't want it to reformat, just compile your code with G++ instead of compile. And quote of the day: I see people hit up arrow just to find ls. Yeah, it's a true story. Like it's a bit of a meme actually in the Unix community. Unix up arrow ls. I don't know. I've seen memes out of that before. Yeah. Up inner ls is faster than ls inner. That's true, but like when they go back like 20 commands to find it, it's like maybe it's because they don't know control U. Like at a certain point, you've got like all these letters on your command, and so if you had to backspace erase them all, like you're kind of stuck, right? So control U erases the whole thing. Okay, and then you can type A instead of A.out. I have an alias set up for that. So in Unix, alias. I've got aliases set up for a lot of things. Okay, and so what an alias means is you can type A.out. That's cool, or alias A. So I've created an alias called A that runs A.out. Okay, and if you want to list all of your aliases, you can just type alias and hit return, and it shows all the different shortcuts. So like Acrobat, you can just type acro instead of acro read. I've got shortcuts to the different directories I use, like you saw me typing CS or CT or CH. These are just shortcuts that jump to different locations that I use a lot. If I want to back up all of my SQL databases, I've got a command just called dump, and it dumps all databases into a file, and then I move that file onto some backup repository or something. I've got different prompts set up. So you're going to change your prompts, P1, P2, P3, P4. Shows the current time, shows the name of the machine you're on. I use this one because I'm always on the local host. I'm not really jumping around between different machines too much. If I was jumping between different machines, then I would use this one, or maybe this one here, just so I could very quickly see which machine I'm on. But I'm always on this machine, so. And also it changes the title up here. Watch, if I go up to say go down into the Seaside directory, P4, yeah. So it actually changes the title bar. So it has your username, your host name, and your path name up in the title bar of PuTTY, and so you can actually see down here in Windows like if you got multiple PuTTYs open, you can see, okay, I'm logged in as me on the server in that directory, and you can switch back and forth between them that way. I could have been typing in C instead of compile. Yeah. So if you want, you could do this, alias C compile, and then type compile main.cc. Sure, absolutely. Now, that will go away if you log out. So if I log out and come back in, I did have the alias already set up. Never mind. But if you create a new alias, it's not going to be saved. Yeah, if you want to actually save your yeah, okay, yeah. Never mind. I already have an alias set up for compile, so you can use C instead of compile. If you want to have your aliases be permanent, there's a file you can edit that has all of your aliases in it. Like this one here gets the size of every folder in the current directory, sorts them by size, and shows the top 10. And so I do this a lot when I'm trying to figure out who's eating up my hard drive space. So like I run this and it goes through, okay, my code directory is currently 6 gigs, my lord. My HTML directory is 2.5 gigs. My Seaside directory with all the homework assignments and things like that, it's a gig. My custom TF folder is 770, so on and so forth. And so I run this from like the students' home directory and find out which students are eating up my hard drive space. I used to have quotas installed, and that was kind of lame because like if you fill up your quota, you can't do homework anymore. So I just ask you to not fill up the hard drive if possible. Oh yeah, the Pokédex is kind of big too. So if you want to edit the file that has the aliases, well, there's an alias for that. So if you type VC that edits your .cshrc file, that's where all the aliases are. So if you type VC, that'll bring up that file where you can edit your aliases. And if you want to compile it, it's SC, which is also an alias. So that'll rerun the CSHRC file and update your aliases. So if you want to add a new alias, type VC, come in here and type alias Bob to cow, say Bob, hyperable cat, something like that. Now if I just edit the file, the alias doesn't exist. You have to log in again and then the alias will exist. But if you don't want to log in again, there's a command called source that will rerun your the file. So if you do that, and then when you type Bob, it will run the new alias that you have set up, and that's permanent now. Every time I log in, it'll be there until I delete it. Okay. But the alias will still exist until I probably until I log out. Actually, okay. Do you have the Quake game on the server? Of course. Yeah. Mm-hmm. You go back to the alias screen real fast. Yeah, if you type alias by itself, that shows you your aliases. But if you type VC, that brings up the file that they're all saved in, and so you can gaze upon my aliases and wonder. Ozymandias says, "I, Ozymandias, King of Kings, gaze upon despair." Do you have an alias for the F word? Probably. There's a command called. Yeah, there we go. Yeah, it's actually a real command. Oh, I don't have it installed right now. Oh. If you make a command and it doesn't work, you just type that, and then it looks at your previous command and tries to figure out what you did wrong, and fixes it. So yeah. It's a legitimate thing. So let's see if I try CSI and then I type what? Let's see. Yeah, you're all in college. You can deal with it. But basically, yeah, if you make a mistake, you type that, and then it fixes your previous command. It's a real thing. It's a real thing. Yeah. So, I think it. Yeah. See, there you go. See, so you mess up, you type the F word, and then it's like, did you mean to do that? Yep. And it fixes it for you. So, yeah. Bruh. Who am I? What is love? Who is love? Me. It's me. All right. All right. So, Unix shortcuts, and then C++ shortcuts. If you want to reduce the value of the variable x by 7, you could type x is equal to x minus 7, Again, math people's heads go, try canceling out the x on both sides. Now, this says set the value of x to be the current value of x minus 7. All right, so it does the right side first. It loads the value of x. If it's 10, then it subtracts 7 from 10, giving you 3. So x is now 3. So rather than typing this whole thing out, you can type this instead. And this is useful if you have a variable name that's really long. So if your variable name is like, hi, I'm a really long variable name, you would have to say, hi, I'm a really long variable name, equals, hi, I'm a really long variable name, minus 7. And so by doing this, minus equals, or you can do plus equals, or times equals, or divide equals, or modulus equals, you don't have to type the variable name twice, which is nice. And there is a specific shortcut just for adding 1 or decrementing 1, and that is x plus plus. So if you want to add 1 to a variable, which happens all the time, it's the most common thing we do, adding or subtracting 1, you can say x plus plus. If you want to subtract 1 from x, you say x minus minus. There's also plus plus x and minus minus x to add 1 or subtract 1, and Zybooks, I think, goes over the difference for you guys. The difference only matters if you put them into compound statements, where you say, like, y is equal to x plus plus. And my advice for you is to not do that. Because there's some really dangerous ambiguities that can arise as a result of combining plus pluses with other commands. So if you just put it on its own line, like this, x plus plus, if the value of x was 5 before, it is now 6. And if you typed plus plus x, type plus plus x, it would do the same thing. When it's by itself, they're identical commands. And then there's x minus minus to go down 1. There's minus minus x to go down 1 as well. The difference between x plus plus and plus plus x only matters when you combine it with something else. Like x is equal to x plus plus times 5 plus 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 x. This is how I got hired, by the way. Let me show you something horrible. Let me show you something disgusting. Doesn't work. So if I put in 5, this is going to output 12 somehow. X plus 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 x. So x becomes 6. It adds 6 plus 6 to get 12. And then when we output x again, x is 7 because it got incremented once there. Don't write code this way. This is how I got hired, by the way. They gave me my choice of 5 different prompts for the hiring committee to become a professor here, and full-time tenure track professor. And most of the questions were like fairly, they're pretty good. But one of them was explain how to increment a variable. And I'm like, really? Adding 1 to a variable? You want to hire professors based on if they can add 1 to a variable? I'm like, wait, this could be fun. And so I threw this kind of thing up on, like, I started off by explaining the basics, how does plus plus work, and then how does it work when you combine them together, and ended up with this gloriously ugly mess that if you type it wrong, summons demons from hell. So be careful. X plus 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 x. And they all got it. Like these were like chemistry professors and math professors that basically never programmed. And I walked them through this glorious mess here in 15 minutes. And they were like, I guess we'll hire that guy. So, that is a monstrosity. It is indeed. It is indeed one of the ugliest things I've ever seen in my life. But I was like, challenge accepted. You want to teaching adding 1 to a variable. I will teach you how to add 1 to a variable, sir. We will do this. And it will be glorious. So yeah, that's actually how I got hired. So, yeah, so the difference between this and this only matters if you put them into a compound statement, like this unholy thing here. So just don't do it. It's my advice. By the time you get to 41 or 26 or 45, maybe, for now, just don't. And if you ever wondered where C++ came from, the term C++, why is it not C+? Why is it C++? Well, C++ is 1 higher than C, right? There was the C programming language. And so when Bjarne Stroustrup came out with his version of C with classes, which is what it was called, the name he came up with for it was C++. It's 1 higher than C. 1 better. And then why would you ever do this? I wouldn't. I would never write code that way. It's job security, maybe. Like if you write code like that, nobody can figure out what your code's doing, and their heads will explode. You could of course always do x is minus equal to minus 1, right? So this you could do x plus plus, right? If you're boring. But then if you do x minus equals minus 1, that of course is also a plus plus. Right? Do you see that? That adds 1 to x. So if x was 7, after we do this, x will be 8. And if we do this, x will be 9. This is a different way of doing x plus plus. Yeah, C# is 4 pluses in a row. Okay. So, and of course, you don't write it like this. Because white space doesn't matter, you write it like this. This is balanced, as all things should be. So that is the professional programmer's way of doing an increment. X minus equals minus 1. You're a musician, so sharp means something different to you. Yeah, that's why it's called C#, because it's the hashtag symbol is the sharp in music. So C# is a musical note, right? And it makes you sound like you're sharp. If you're programming C#, you must be a sharp person. It's got that connotation of being intelligent and brilliant and music. But if you look at it, the hashtag is plus 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 plus. So it is literally C++ plus plus, which is C#, or C#, as my Czech friend called it, D flat. If you want to cast shade on it, yeah, I'm a D flat programmer. Right. So the octothorpe, it's amazing. The octothorpe. Yeah. So yeah, don't take me too seriously when I'm talking about this. But this is Thanos, of course. E flat flat flat. Yeah. So yeah. Okay. I used to only think in sharps instead of flats for the longest time playing guitar. It makes my jazz friend mad. Yeah, sharps are always easier for me when playing violin, because when you do a flat, sometimes you have to go to the next string down. And so my finger's already on the one string. I'm like, oh, damn. And I have to drop down a string and slide up. And I just botch the note, Whereas with a sharp, if you're on F, you just go, whoop, you just move your finger down a little bit, F sharp. Cool. But if you're doing a flat, you sometimes have to go down a string, right? So nobody ever talks about a B sharp. There is no B sharp. See? Yeah. Right? The forbidden note. I'm a B sharp programmer. Yeah. Okay. So, yeah, I hope you had fun with that. There's different things like that. Instead of couting X and Y separately, you can chain them together like this. This works just fine. This is, in fact, how it was designed to work. So you can just put together multiple things, and it just goes through one at a time. It'll print out X, then it'll print out a new line, then it'll print out Y, then it'll print out a new line, and the new line is, again, the enter key. Okay. Reading a piece in C# has a B# in it. music theory. I frankly, like, I hang out with Max sometimes, our music instructor on campus, and it's just like, I know a little bit of music theory, but like, damn, like, music theory would be complicated. You think computer science is hard. I think music theory is harder than computer science, to be perfectly honest. Okay. Or it might just be because I don't know it. Who knows? So, and then the key shifts up a fifth. You go into G sharp sharp. Or like a half sharp. You've seen those before. I'm trying to open input file 10 and the preamble of the Constitution. It's the Declaration of Independence. It's not the Constitution. Yes, and so Hesterberg, what's happening is you're thinking the user is going to type in the number 10 or something, right? What's actually happening is the user types in the entire preamble to the Declaration of Independence, which is exactly the point that I'm trying to convey to you guys about vetting input. You never should believe that the user is going to give you what you ask for. Please type in your name, -0, right? There was a last night I was getting dinner with some friends, and they were talking about how guns weren't tested properly. Like Sig Sauers, if you drop them at a certain angle, they would go off. And that's bad. And so we had this interesting conversation about how, like, learning to test things in computer science, like, if you apply that mentality to, like, the gun world, like, it probably would have stopped Sig Sauer from almost, maybe going bankrupt. I don't know. So, Max is great. Yeah, I like him a lot. If I have a bunch of ifs and print things, can I just see on an inline after the ifs? Yeah, of course. Yeah. Oh, I shouldn't say of course. Yeah, absolutely. Yeah, anything to cut down the amount of typing, I'm all for. Instead of using an inline, you can use \n. Usually if I end a line with a string, I just type the \n. That's the same thing as the double left arrow inline. The double left arrow inline is 8 characters. This is 2, so I use it. There is a technical difference between an inline and a new line. The inline calls flush on the output buffer. So does \n, but only when it's writing to the screen. So there's a really obscure edge case where if you're writing to a file and your code crashes, this line will appear, this line will not. Don't worry about it for now. They're more or less the same thing. But when you get into like junior level computer science, you probably should learn at some point the difference between inline and new line. If you're writing to a file, this will sync the file. It'll make sure all the data is in the file before it goes on. This will not. Okay. But when writing to the screen, they behave the same way. User inputs. Adolph, Blaine, Charles, David, Earl, Federer. Yeah. You have to expect the unexpected. You have to expect when you're handling input that the user will give you something completely wrong. And that mindset for testing is really important. And that's why I start with it. Like a lot of computer science programs, they teach you testing like your junior year. At that point, all of your habits are ingrained, and you're not used to thinking about everything that could go wrong. So, no, your first homework assignment, you're getting the bloody Declaration of Independence when you're expecting an integer. Okay. Yeah, a name that's like 500 characters long for sure. Yeah. A lot of people store names in like 80 character buffers. And so if you type in a name longer than 80 characters, it overflows, corrupts memory, quite possibly gives you the hacks. So, okay. You can use \n inside of a string, and you can do this: A \n, B \n, C \n, D \n. This would be really expansive if you did it with inlines, right? A close quote, double left arrow, inline, open quote, B, close quote, double left arrow, inline. Yeah. Why not the entire B movie script? Yeah. What's really funny is, I don't know if you guys know a game called Stellaris. It's made by Paradox Software. It's like a 4X space conquest game. They don't have any size limit on the usernames. And so when you type in your username, a friend of mine pastes the entire B movie script into his username. And so every time he says something like, hi, it prints his username, which is the entire B movie script high, and it floods the entire screen. Yeah, or like the Navy SEAL copy paste or things like that. All right, so let's talk about Boolean variables. Okay. You like Chaz? Do I like Chaz? Or is that, I mean, I at this point I don't even know what's reality anymore. Oh, okay, gotcha. All right. Nothing is reality. Yeah, it's just like how many levels of meta memes can you go down until like what are we talking about? Gotcha. Okay, so Booleans are a new type. So far we've learned ints and floats and strings. One thing about strings, because this will be on your Xi books, I guess, is if you have a string like this, string s equals hello world. If you want to print a particular letter from a string, you can do it like this. And this will print the 0th character, which is H. Okay. So if you want to grab individual characters out of a string, you can do that. We're really going to study that at a later date, but you might need to know that for the Xi books. And if you want to change it, so if you wanted to like change hello world to like Jello world, like that. So single letters have single quotes around them. Multiple letters have double quotes around them. So this sets the first letter in the string, which is H. It'll set it to J. If we run that, it now says Jello world. Okay. All right. Strings are arrays by default. They're actually vectors, so they're probably the better way of doing this is to do that. So that sets the 0th character J also, but it does bounds checking. So if you do something stupid, like try editing the -1th letter, did I freeze this? When you try running it, it crashes. It doesn't allow that, which is good. You want it to crash. This thing does what's called bounds checking. It prevents your code from running out of bounds. If you did it with square brackets, nothing happens, right? Which is bad. You actually want your code to crash if you do something incredibly stupid like that. So I think Xi books might use square brackets, but just use this if you want. If you need to access an individual letter, if I want to access the, I don't know. The W here, the W is 0, 1, 2, 3, 4, 5, 6, counting the space. Hello, Gerald. Use nested loops. There shouldn't be any loops in simple calculator. Okay. No reverse indexing. Yeah, that is something nice about Python, where you can go in from the end. You can also slice things using colons, which is really nice. How many characters can each space in the string hold? Each space? Every spot in the string holds one letter, right? So s.at6 holds a letter. Spaces do count as characters, yeah. So that's why this is 6, right? H is 0, E is 1, L is 2, L is 3, O is 4, space is 5, W is 6. Yeah, so spaces do take up a space. They're one character. Practice is what I just talked about. If you want to edit the 6th letter of a string, you can do so like this. So, yeah, don't worry too much about that. We're going to talk about strings at a later date. So Booleans. So Booleans are a new type. We've learned ints, floats, and strings. Now we're learning Booleans. And the good news about Booleans is that they're really easy to learn. They're basically integers that can hold 2 values. So there's true, which is 1, and there's false, which is 0. That's about it. That's it. They can be true or false. And you can write out true or false, or you can use 1 and 0. Either way, it will work. So You can do equality, comparison, knots, assignments with them. Basically, they just kind of work the way that an integer works, except you just can't do addition, subtraction, multiplication, or division with them. All you can do is assignment, comparison. And that's it. You can't plus equals them. Maybe you can. I think you used to be able to do that, actually, but you shouldn't. All right. Can you set x equal to not x? Yeah. That's a very common thing to do. Right, like... we haven't learned loops yet, but basically we do something like this. We do something like this in a loop. Like, let's say you're making a chess game or Pokemon or checkers or something like that, where somebody gets to go first, and then it's the other person's turn, and then it's the first person's turn, and then it's the other person's turn. So, if it's first person's turn, then it'll say first person's turn. And if first player is false, then it's the second person's turn. Then after you finish all that, you say first player is equal to not first player. You guys see that? So that is saying if first player was true before, it's false now. If it was false before, it's true now. And so if you put this code here into a loop, and I'm not going to show you loops yet because I don't want to confuse you, but if you put this code into a loop and it runs over and over again, it'll go back and forth, first player, second player, first player, second player, first player, second player. And you just keep doing that until somebody wins or draws. Yep. So if you need a 3-value comparison, yeah, like Mr. Bell says, you use an integer or something like that. It's like if you're in a 32-player game, you can't use a bool, right? You have to use an int. And so you'd have an integer saying current player's turn. It's currently 7th player's turn. Once they're done, increment it. Something like that. Bool is mainly used on true and false. Bool is only true and false. It is only true and false. It used to be possible to do something like this, like first player plus plus, right? This might even still compile. No. Yeah, they banned that. It used to be legal, but they banned it. So that adds 1 to it. So if it was false before, it's true now. It was true before, it's still true. Maybe, who knows? It's extra true. I don't know. Yes, they got rid of that because it's undefined behavior. If you set a boolean to anything other than 0 and 1, will the code handle it? Who knows? Yeah. So they banned in C++ 17. If you were to compile it in std equals C++ 11, if you compile it in an older version of C++, it'll actually compile. It just gives you a warning instead. So don't do this. Right? All you can do with a boolean, don't do that. First player, you can say first player equals true. You can say first player equals false. That's about it. True. False. And then check to see if it's true and false. That's about it. That's a boolean. It's an integer that can either be 1 or 0. That's it. So it's like an integer, but much more restricted. Half of all C++ is undefined behavior. Yeah, you're spouting truth, Zach. They did clean this up though. They actually did just say no, it's illegal. Before it was legal but undefined, and then nobody could come up with a good argument for why it should be illegal, so they banned it. They deprecated it for a while, so you get a warning that you shouldn't be doing it. And then when C++ 17 came out, they just like, nope, won't compile. And fortunately, there's absolutely no reason to do ++ on it or plus equals 0. I guess works. It's not doing anything. But, yeah, those are booleans. You guys have any questions about it? True is 1, false is 0. Yeah, for booleans. For integers, int x equals 5 if x. See how. Please enter x. If I put in 3, it's true. If I put in 1, it's true. If I put in 100, it's true. If I put in 0, it's not. So in C++, 0 is false. Everything else is true. It's just with a Boolean, can only be 0 or 1. True or false. So 1 is true, 0 is false. But more broadly in C++, the definition is 0 is false. Everything else is true. So while it is true that 1 is true and 0 is false, broadly speaking, it's 0 is false, everything else is true. Okay. That's how it's defined. Negative 0 equals true. Negative 0? Nah, it's false. When you initialize a variable to be 0, is it reading it as false or 0? It's the same thing. Same thing. False is 0. There's no separate false value inside of the computer. If you were to like open up first player equals false. So if you were to just like output first player, if you just output first player, it's 0. Like there's no secret false value. It's literally just 0. And then after we flipped it to true, it's now 1. Okay. So if we were to just output a Boolean that's false, 0. If we then make it true, 1. Okay. There's nothing secret going on behind the scenes. It's just 0 and 1. Okay. And so you can write it out as false, or you can write it as 0, and under the hood, what happens is it's just 0. Okay. Empty strings evaluate to false. That's a good question. Can you still see out bools? Yeah, you can see out a bool, and yeah, it'll do that. If you wanted to print true or false, you can type in cout bool alpha like that, and if you do that, then you will get false and true instead of 0 and 1. Okay? So if you want it to print the words false and true, you can do so by doing that right there. It looks a little nicer. I usually do that if I'm outputting Booleans. But what's happening under the hood, false is 0, true is 1. Okay. And see, it didn't have a Boolean, so you had to make a variable false equals to 0. Yeah, you'd hashtag define it usually. And people would oftentimes hashtag define their own Boolean type in C as well. I think they added it, didn't they? Like C99 added Booleans, didn't they? Because everybody was doing it, so I think they stood bool. Yeah, they added a Boolean type in C99. I think under the hood they're still just integers. Okay. that's our class for today. Bools are, I don't know. I don't know how to make them hard for you guys. So. That's, yeah. Those are booleans. It's just an integer that can either be 0 or 1. Okay. So I'll see you guys on Wednesday. I will throw up the competency exam tonight. Brush up on your booleans. Maybe get your Zybooks done before taking the competency exam, just so you're extra prepared for it. It'll go over everything we've covered in class so far. So everything's fair game. Everything I've talked about in lecture and on a PowerPoint, it's fair game. So treat it like you're going to treat a midterm. Study for a little bit. It's going to be looking like a 4-question quiz that you have like 10 minutes to do or something. But the challenging part's always the coding, because you actually have to produce good code. Okay. It'll be due in a week. So you'll have a week from today to do it. And if you fail it, then you get to take it again. So not a big deal. Booleans for Booleans. All right, everyone. Thank you for a good class today. I hope you had fun with the x equals minus 1. And I'll see you on Wednesday. All right.